All right, 2 minutes after, so let's get started. My name is Jonah Chiarenza, and I am happy to be working with the Active Transportation Data Working Group to welcome you to this month's conversation with colleagues, or quarter. Active Transportation Data Working Group is, I don't know how long we're going to have to keep saying this, maybe for a year, and then we'll have done the sitting Shiva and we can move on, shave our beard. But for now, we're reflecting on our prior status as a subcommittee to the Pedestrian Bicycle Committee as a TRB. Just because that subcommittee doesn't exist anymore doesn't mean this work isn't still ongoing and important. So it's great that with Krista's leadership and others who've been involved, this group continues to persist and host events like this so that we can get together and be nerdy about active transportation data. So the conversations with colleagues quarterly meeting has these sort of shared goals. Our goals are basically to convene folks who are data wranglers, talking about ped bike related small things with wheels, and identify opportunities to delve into certain topics that are relevant to the community, find people among us in our group who are conversant or working on relevant topics and bring those out so that we can discuss them. This is foremost a conversation, so while we have presentations today, we are going to try to get through them quickly and then can bounce back through the slides as needed to address an open dialogue on this topic. So today we are going to be recording, and the session will become available along with the presentation on the Google site. Ground rules, be nice, raise your hand, and yeah, let's get started. So today we have 4 presenters, Justyna Goworowska from the Bureau of Department of Statistics, Will Rogers III from Greater Nashville Regional Council, Josh Roll from Oregon DOT, and Jiahui Ma from Portland State University. So without further ado, I'm going to jump into the beginning of GATIS with our guest, Justyna.
Thanks, Jonah. All right, let's get going. Thanks for the opportunity to chat with you about General Active Transportation Infrastructure Specification, or GATIS. Next, please. So the work on this project started in December of 2023 by convening a national collaboration on bike, pedestrian, and accessibility infrastructure data, NCBPAID, if you've heard of it or were involved. The GATIS is the product of that collaboration. And we convened the collaboration because we recognize that there are gaps in the nation's bike, pedestrian, and accessibility infrastructure data. And that data gap has some very important impacts. It makes it hard to get around. There's no federal or state guidelines that dictate how to collect these data sets, and this creates this patchwork of data sets across the country. Makes it difficult to combine them. For us at BTS, specifically interested in a national level data set, we're unable to accomplish that goal without having a standard for all of these data sets. It's hard to do any asset tracking or maintenance, and it really has the most important impact is on safety, because it's really difficult to make safety improvements if you don't have a solid understanding of your bike ped and accessibility infrastructure landscape. Next, please. So in response to that, we launched our collaboration, like I said, in December of 2023, and we are actually now in the process of sunsetting that collaboration, but I'll talk about that more in a little bit. But at the peak, we had 350 individual members across 200 different organizations, from local, state, federal government, research institutions, for-profits, and nonprofits. And we converged around developing open standards and practices, because we recognized that the best way to solve this data gap problem is to work on a shared data specification. And we're now with the release of the first version of GATIS, working on facilitating adoption of these standards by both data producers and data consumers. And if you're wondering why BTS is involved and was involved in this project, it's because under Federal Geographic Data Committee, we are responsible for transportation data, and that's where guided our involvement in this. And like I said, selfishly, we're interested in having a national data set of these active transportation infrastructure assets. Next, please. So a few things that guided the mission for the spec was to digitally represent the physical infrastructure for walking, biking, and rolling in the US. We designed it with travelers of all abilities in mind, and we also considered the transportation needs and land use patterns of the entire country. So we weren't just focusing on the urban landscape, we were considering suburban and rural areas as well. We analyzed probably over 80 different use cases for GATIS, and we identified two major themes that GATIS supports. One being profile-based routing, and the other improved asset tracking and maintenance. Those are just two out of many, and even though we focused on these general themes, there are many other use cases that GATIS supports. Next, please. So I mentioned profile-based routing being one of the use cases that GATIS supports. So just to get us all on the same page, a routable network is a geospatial representation of physical infrastructure that is comprised of nodes and edges, or vertices and links, depending on which language you end up using. And it simply enables computer systems to calculate paths between nodes. I'm sure many of you have heard this definition, but just wanted a quick refresher. Next, please. So part of the structure of GATIS is the tier model. If you've seen any of our previous conversations, or if you've been involved in any of the work, you've heard about the tier model. And the tier model really just aims to meet data creators where they are by providing a minimum set of requirements and a suggested roadmap for increasing the completeness, precision, and other aspects of their data. We also see this model as providing guidance on best practices for those that are creating new data sets. So as you can see, there are 4 tiers numbered from 1 to 4 in order of increasing detail and completeness. We don't provide any kind of recognition for achieving a particular tier. Rather, we really see this as a mix and match model. You can have pedestrian data be at one level, bike at another level, or you can similarly have tier level 2 when it comes to spatial precision, but tier 4 when it comes to completeness of your attributes. So it's not prescriptive. Like I said, it's meant as a guide, and I will get into a little bit more detail of how this tier model is expressed in the pedestrian and bike network in the upcoming slides. Next, please. But before I jump into that discussion, just wanted to highlight our GATIS Explorer page. That's where you can really familiarize yourself with the specification, check out the playbook, which is the technical documentation for GATIS. We have some sample data sets, pedestrian network for Austin, Texas, and a bike network for Newark, Delaware. You can also check out the prototype of the GATIS validator and peek at our GitHub page, which is where majority of the NCB paid content and past meetings can be found. All right, let's continue on. So I'm gonna hop into talking about the pedestrian network first. So at tier 1, we're really talking about a very basic representation of just your sidewalks, crosswalks, and curb ramps. Most likely, this data is not routable, and very often the information about the pedestrian network will be attached to the road center line. The attributes that we're asking for are very minimal. We're just asking for the type of facility it is and the node or edge ID associated with it. Next, please. At tier 2, we are increasing the number of features, asking for things like trails, multi-use paths, and traffic islands. You might be starting to separate your sidewalk network from your road network, and we are starting to ask for more attributes such as width and incline, cross slope, the surface material. Throughout all the tiers, ADA compliance remains a recommended attribute rather than a required attribute. We made a conscious decision to prioritize the objective description of the infrastructure, so things like width and incline, rather than something subjective like the sidewalk quality being good, or even ADA compliance sometimes might not give users the information that they're looking for. That's why we keep that as recommended and the other pieces as required. Routability is likely possible here, but it can have some gaps and imperfections. At tier 3, moving on to the next slide, thank you. We're adding more features. You can kind of sense a theme here. Things get more complex with more features and attributes. We're adding some curb ramp details that are not present in the previous tiers. You start seeing things like the transition spaces between the road and the curb ramp itself. And routability at tier 3 is likely the network is fully routable using spatial topology. Next, please. And at tier 4, very similarly to tier 3, we're adding a little bit more details on the curb ramp. We're adding some more features. We're adding an issue node, which is that orange dot on this image that allows you to have a break in the edge and do like mid-block routing, for example, if there's an obstruction in the middle of your sidewalk. And then again, the data is most likely fully routable either with spatial topology or metadata. Next, please. So moving on to walking through the bicycle network overview, it's a little different than the sidewalk overview you just saw. With sidewalk networks, you're most likely going to have some road centerline representation at the lower tier levels, but probably individual network representation at the higher tier levels. With bike network, it really depends on the type of bike facility you're working with. So for road centerline representation, this is really appropriate for things like a painted bike lane, which is what you have in this example. And we have that orange line representing the road edge. And that table tells us that there's a bikeway on both the left and right side of the roadway. Next slide, please. With network representation, this is really suitable for bike facilities that are separated from the road. So they either deviate from the road completely or they are separated with a physical barrier, which is what we have in this example below. It's a two-way cycle track separated with a concrete barrier. And that gives us a separate edge for the road and a separate edge for the bikeway, which is shown in that dashed orange line in the image. So with that in mind, let's go to the next slide. I'm just going to breeze through the next few slides because it's somewhat similar to what you saw with the pedestrian network, but we require some very basic features at tier 1. And again, they can be expressed either as network representation or roadway centerline. We're really requiring only basic attributes, just edge ID, edge type, directionality, bike weight type. So whether that's a bike lane, a separated bike lane, a two-way cycle track, or a multi-use trail. Next, please. At tier 2, the number of required attributes increases, including things like width, separation elements, so whether it's a concrete barrier, flex posts, the permeability of the bike facility, so whether it's a hard, soft barrier, or if there's no barrier at all. Tier 3 is the features and network type basically stay the same, but the required and recommended attributes expand, and the network becomes fully routable through spatial topology. At Tier 4, not much changes. We are adding some more recommended attributes. And again, the network is fully routable either with spatial topology or metadata. We also have added things like intersections and relation tables and better data for local roads and points of interest. And I also wanted just to highlight that GATIS can map a lot more than just the things that I breezed through. We can add things like driveways and grade separated infrastructure, traffic calming, signs and signals. We also have transit stop integration with GTFS by adding things like stop ID and agency ID. So there's a lot of things that GATIS enables you to do. And with that, I will turn it back over to Jonah. Thank you so much.
Great, thanks, Justyna. If folks have questions, please go ahead and start putting those in the chat. And we're going to go into the... Thank you, Justyna. The lightning round. And kicking us off. And you guys are supposed to only do this 5 minutes apiece, okay? So you promised me. We're going to go to Will.
Hey guys, I'm Will Rogers. I'm at the Greater Nashville Regional Council. We do a lot of the MPO stuff and more. I'm the safety planning coordinator, and I've been playing with GATIS and trying to come up with ways that the MPO can get our cities to adopt it. And so I started with this intersection just to see how it would look to build a tier 4 network from scratch. So eventually going out with level, or my friend has a robot and it's got a device on it that can tell me the slope and cross slope. So I encourage you to go to the Explorer page, because the city of Austin converted all of their lines into, I think, tier 2. So there's Python you can use to convert your whole city network into GATIS. The approach I'm taking is like, what are the issues that I can find to highlight to the team when you start out from, we're going to end up with tier 4. Let me find all the nitty-gritty details. So next, please. This is an intersection near where I live in Nashville, Tennessee. And here's what the edges layer looks like. So I drew an edge on all the crosswalks and the sidewalks. I didn't go further east-west on this road, but just to get a feel for it. So there's a line for each crosswalk. You see on the left side and the bottom leg, there are marked crosswalks. And so there's a field that not only gives the edge ID and all, these, but there's also a field that's like, is there presence? So legally, that is a crosswalk on the right side. There's a sidewalk from the bottom that points across the intersection, but there's no markings. So there's a field to say there's a legal crosswalk here, but there's no markings. Next slide. So that's edges. The nodes is the, where the edges connect. So every edge has to have a end, and that's where the nodes begin. And in this case, it also has data on the curb ramps. So you see open. That's where the crosswalks are open. And then I said, well, the crosswalk on the right is closed. So that's reflected in the curb ramp data. And if you go to next, you'll see points. So on the bottom right, there's a spot where the traffic control box is an obstruction to the pedestrian access route. So there's only 18 inches of that sidewalk width that's available for me to walk. So even me, I'm kind of like going sideways into the bushes. But for someone in a wheelchair, yeah, that's not, you need at least 48 inches or 36 inches to pass the device, but your arms and all these things. So that's a point that someone in a wheelchair or other device would need to know, hey, don't route me on this sidewalk because I literally can't physically get past that spot. And then on the top left, I just know from taking the bus all the time that that curb ramp gets flooded with debris. And so you never see the detachable warning surface. It's always covered. So if I was blind, my dog or stick is not going to necessarily see the device. So next, this is a different intersection, but focus on the bottom left, that pink area. That's what a zone looks like, I suppose, and it has its own attributes associated with it. So in this case, the zone is a pedestrian promenade where there are bollards kind of represented by that wheelchair sign. But this is another example where I'm trying to think of, hey, this bridge used to be open to vehicles. Now there's kind of these sidewalks. And so I'm trying to, you know, show different examples across the city. Next slide. And then lastly, this is an actual project in Nashville. It's called All Access Corridor, meaning the transit agency and the city have a lot of money to actually build transit-only lanes, or high-frequency transit all the way from downtown in the north all the way to the south. And so I'm thinking, hey, where along this corridor could I show the current network in GATIS Tier 4? And then when it's built, let's see how it's changed. Next slide. And I'll just kind of show you this existing conditions. You have bus stops with bike lanes and so on, 5-lane road. And then the last slide, concept for a different corridor, but it could happen here. So how does a city like Nashville use GATIS to show the before and after improvements? And then, you know, I'm trying to get cities like Nashville to incorporate GATIS, that consultants and cities and NPOs can all just use the same format. Thanks.
All right, my turn.
Thanks, Will.
Well, good to see
Josh.
some familiar faces and folks I haven't seen in a while. My name is Josh Roll. I'm a researcher at Oregon Department of Transportation, our research section, and we work on a ton of different safety-related projects focused on bike and ped, and always struggle with data. I won't lay out the whole genesis of my involvement, other than to say that I met Justyna at a TRB way long ago and shared with me this work and the confluence, and I shared with her the confluence of this of the GATIS effort, with some of the challenges and planned efforts at ODOT. And so it's all maybe a little bit of a plug for why it's so important that we continue to send state staff to places like TRB, and the importance of TRB, even given the challenges that world is under at the moment. But so I'm going to share just a little bit about some ongoing work at ODOT and how we are aiming to fit our newly collected multimodal inventory data, our bike ped asset data, into the GATIS standard. And so about 2.5 years ago, Oregon updated their transportation planning rule. That's the TPR mentioned here. Transportation planning rule focuses on ensuring that ODOT meets some of its VMT, vehicle miles traveled reduction goals, and coordinates with land use authorities to make sure that land use and transportation are planned in conjunction to mitigate driving and all the externalities associated with it. And the TPR goes back a long ways. The TPR was recently updated to say some things about the need to report through our transportation system plans, needing to report on build-outs of the bike and ped system. The local agencies that are tasked with doing that work squawked and said, hey, you can't make us report on these inventories because we don't even have the data. And so ODOT stepped up and said, well, we'll help you collect it. We'll do that consistently across the state. And through that process, you'll be able to report and then hopefully use the data for all sorts of other applications other than just reporting on the build out of your sidewalks and bike systems. So ODOT's been coordinating. I'm not leading that work. It's a great person here at ODOT, a planner named Teresa Conley has been coordinating that work, pulling in consultants and private firms that can do data development to collect the data using some automation, aerial imagery, and some automated techniques of reading those aerial images and assigning and developing network attributes on the ground, including where the sidewalks are, where the bike infrastructure is. And so a little of what I hope to share today is just some of that process, some things to think about when we're hiring some of these private firms, but then also some of the challenges in getting the data now that we collected into this standardized format. What was really unfortunate is the ODOT work was probably 6 months ahead of where it should have been, given where GATIS ended. If ODOT had started 6 or maybe 9 months later, I think we would have been so well positioned to take the data standards from the GATIS work and directly apply them. And so now we're in the effort of having to conform what is kind of a statewide data standard for bike ped data and get that into the GATIS standard. So, but the goal of this work was to collect, at least in the MPOs, bike and ped infrastructure, along with a bunch of roadway data, do that consistently, collect those data through a process that was QA, QC'd, and then develop a long-term data collection strategy. Slide, please. I kind of went through this and some of the needs here and how it fits into the transportation system plans. These are things, TSPs are items that our local cities do, and all around planning for the future, trying to accommodate growth, population growth, traffic growth, that sort of thing. So I'll skip some of this and go to the next slide, because we are going to hear later about how we tried to get some of these data that we've collected through the MMI into the GATIS standard. And for the most part, we have a lot of the attribution, but the way in which the data was collected using some of the automated techniques, they didn't build a routable network. And so we are now working on how that process is going to work. We're contracting with the University of Washington and Anat Caspy's group at the Tasker Center to help us figure out how to take all these now, for first of their kind for the state, multimodal inventory data and get them into a routable network that conforms to the GATIS standard. All to help support some of the transportation system planning, safety analysis, VMT reduction goals that the state has. I think that's it for me.
Great, thanks, Josh. Jiahui?
Hi, thank you. Nice to meet you, everyone. I'm Jiahui Ma from Portland State University. I'm a PhD student working with Track on this project, along with Sarisha Kusuri and Krista. So I'm going to talk about really into the weeds of how we converted the ODOT data into GATIS format. Next slide, please. So overall, I think there's 4 steps. First, review what the current data structure is and identify the AT features that GATIS is requiring. And the second step is to identify what's the attributes requirements from GATIS. And the third one is, which I think is really important, is to document and create an attribute crosswalk. So we know like which attributes is going to which GATIS variable and how the values are being translated. And the last one is actually convert the data. So a lot of the things, most of the work happens in the preparation stage. Next slide, please. So for the ODOT data, which I think is probably what most agencies' data structure currently is we have roadways, pedestrian routes, bike routes, bicycle and pedestrian crossing, all in individual layers. But in GATIS, all the edges features is going in one layer, and it's identified through edge type. Next slide, please. So for the GATIS tier system, as introduced before, this is a screenshot I got from the GATIS Explorer. And as we can see, for sidewalk, different tiers have a different set of required and recommended and optional. Those are the things that could happen in there. So all these attributes for sidewalk in different tiers. So to do the conversion, the first thing is to understand what are the requirements. And next slide, please. So what we did first is to go through the GATIS variable and the corresponding variable in ODOT dataset, basically going through one by one to see which of the ODOT data variable could possibly provide some information for the attributes that GATIS is requiring. For example, primary users basically maps to allowed uses, and then there are other more indirect correspondence, which I'll go into details in the next 2 slides. So here are some examples of what happened, like all the decisions made during the conversion. The first one is a combined source mapping. That's just a fancy way of it's multiple variables mapping into one GATIS variables. So in GATIS, visual markings describe whether a crossing is marked and when available, the types of markings. So there's not only yes, no, there's also dashed lines, zebra, continental, ladder, transverse, and other type of markings. And in the ODOT data set, there's this type 1 attribute that's basically marked and unmarked. But then going into the data itself, I noticed that there is another data set, there's another attribute that actually has some more information about whether this is a standard or ladder or continental. So what happens is combining these two into the visual markings attribute. Yeah. Next slide, please. And another scenario which I think might be happening more often is a partial partial match. So for GATIS, as Justyna mentioned, what they're trying to do is for variables as much the variables needs to be as objective as possible. So for example, surface issue, instead of qualitatively describe it as in good condition or poor condition, specifying what are the issues like crackling, uneven, as Will mentioned before, maybe there's a lot of debris on there. So in the ODOT data set, there's this condition variable, but it's a subjective variable based on team evaluation, and we don't have really good documentation of how the evaluation is made. So in this case, after discuss with the team, we're thinking what could be useful information for the GATIS format is that for the good conditions in ODOT dataset, it's probably reliable to assume that it would mean no surface issues in GATIS, but for the poor and unknown and fair, there's really no way to see if it is because of there's surface issues or no surface issues. So for those, we'll just leave it as unknown. So a lot of these conversations are happening. I guess the main takeaway from this is that the person doing the conversion really needs to understand what the original attribute measures, how the values are created, and whether the information can be safely translated into GATIS value. Yeah, that's all I have. Thank you.
Fantastic. Thank you all. We have about 24 minutes for discussion, which is great. I see a comment in the chat from Brian. Brian, you want to come off mute and share?
Hi, hopefully everyone can hear me. I'm Brian Pollock. I'm with SEMCOG, Southeast Michigan Council of Governments. So we do bicycle pedestrian planning as part of our transportation department, as well as within the environmental group as far as like parks and recreation. So we kind of share duties between the transportation side as well as some of the recreation side. And we partner with MDOT and the counties and locals, and we have like our own system that we've developed over the years. And I was just commenting on like the way that ours was set up, and I'm interested to learn more about GATIS, but it's like we're just finishing up like converting our stuff over from more piecemeal to this system that we developed, which basically has two networks. One that's on road based off of the stuff that the state gives us. So it's like road center line. And so things that, go along the road, bike lanes or bike routes, etc. Like those would be on road, but if you have a shared use path or a sidewalk, crosswalks, those are off road, and that would be a separate network that we were able to create through aerial photography and digitization to create own sidewalk and shared use path center line. And so like those two come together, and then we use a linear referencing system to append a lot of different data to it. And so like my comment was that one thing that I didn't see was designations for different bike routes of like different levels, as well as the same thing on the trail side, because those can really overlap quite a bit, where you might have a local bike route that's part of a county route, which is also part of like a regional route and part of like a state route. And the same thing, like that's just on the bike side. The right route might be also helpful from a trail side, where you're trying to do both walking and biking. And so like we have a lot of overlap, and in the past like each of that had like its own kind of file, and it was like a lot of spaghetti. And so like we've worked out the system that seems to be working pretty well, but we're always interested to learn more about the what else is out there, especially because when we get like household survey data, or if we get stuff from Strava or like different resources, we want all the data to play nice. So it was just more of a comment because I'm not sure how much that we've been a part of any of the conversations nationally, and I just wanted to make that known and let people know if they're interested, we'd be open to having any further conversations about this or anything else.
Hey,
I
thanks,
can,
Justina. I'm queuing up
yeah.
slides if you want. Go ahead.
Yeah, I was just gonna say, so we do have space to accommodate multi-use paths, but the issue of like different types of facilities overlapping and maybe like having different names, there is some space in GATIS where you can add a name, whether it's a road name or whether the facility itself has a name, but we also don't want GATIS to be limiting. So if there's something that you think is missing that is useful for your data representation, you can definitely make it extensible and add an attribute that works for you. Like I said, we only just released version 1 at the very end of February. So these types of comments is what we need to improve the specification going forward with versions 2 and following ones. So we'd love to have you involved. I was just at ITS America last week, connected with someone from Michigan DOT, which is great because we have not had anyone from Michigan involved. We would love to have Southeast Michigan Council involved as well. I'll put my email in the chat so we can connect, but yeah, love to hear all the feedback that you have.
Great, thank you. And I know someone had mentioned about a conversion tool, so that's always good to know too, because again, we spent significant time developing our system. So if there's ways to like duplicate it and like make sure that it plays nice with others, but it's like easy on us, that's good to know too. So thank you.
Yeah, we have some scripts already that can help you make that conversion. We're going to work on improving that, and we actually have a contract that will be starting soon with some folks that will help us build out some of these tools to lessen the burden on folks that already have data in other formats and make it easier for them to convert it into GATIS. So stay tuned for that.
Does anybody else have experiences or, pains, or just went through a humongous process to do this, and now you're like, now you tell me about GATIS? Thanks a lot. So Amy asks about adding or connecting with behavioral data. Justyna, is that something you could talk to as well?
Yeah, so especially in the road centerline representation, I believe there's space for things like speed and lane count. And those pieces definitely go into the level of traffic stress analysis if you have like an on-road bike lane, unprotected bike lane. And again, like I said in my previous answer, if there's something that isn't in GATIS, we don't want you to, we don't want to keep you from including it. If you have average daily traffic, anything else you want to add that will help with your level of traffic stress analysis, that we can work on making sure that it's represented in GATIS.
I think another component of this is that, there has to be a threshold or an edge to GATIS, no pun intended, where you're like not reinventing the wheel or appending a bunch of information that really exists elsewhere or is updated or, comes from another source and would need to be maintained in two places. That's like the worst thing ever. So by having I think part of the logic of having a linear or a centerline based representation for as much bike infrastructure as possible was to continue to maintain a centerline with rich information about the bike facility that could easily talk to or be linked to other data sets that talk to a centerline based on a universal route ID. And I'll quickly get out of my pay grade talking about this stuff, but the notion is that it's part of a system specific to infrastructure that can facilitate, routing, asset management, safety analyses, and other things where having specific detail about the infrastructure facilitates those types of tasks, analyses, operations, reporting. And so it doesn't need to contain everything. It needs to talk and be interoperable with other data sets based on common use cases like those.
Yeah, thanks for highlighting that, Jonah. We're not trying to replace what's already out there, and we really want to be interoperable with other data specifications and standards. So if there's already something out there that's doing it well, we don't want to reinvent the wheel. And we try to keep the focus narrow so that we can do things well for active transportation infrastructure specifically. Some of you might ask about count data, and we did not venture into that, but having the information on the infrastructure is going to help those that are doing pedestrian and bicyclist counts do their work better. And the Eastern Transportation Coalition is actually working on a specification that addresses counts specifically. So we really want to be working with others' specs and others who are developing this, rather than, like Jonah said, trying to do everything in one place.
And Will isn't here, but he actually facilitated a conversation on the AMPO GIS user group that included information about the active transportation count specification. I guess theirs is in general, so that's okay. I just put a link to a white paper about that. I think
maybe
part
we
of the
can
other thing,
get them to add general to their name just so we can keep the standard going.
I think, yeah, anything to suggest the inevitable momentum of this is going to be helpful. But that's actually part of the, suffering through this alone has been the story since people have started to, try digitizing active transportation data. And it's always sort of gotten short end of the stick just because, it wasn't as in demand, but it's sort of a carrot and stick thing. So trying to make it available, as Justyna was saying, through a specification, the hope is that it actually begets more of the data, and it makes it easier for folks like Josh to contract, or not Josh's colleagues, to contract with a vendor and say, hey, give me this data and do it in this format. And then one stop shopping, you can sort of pay for the tier of data you want to support the use cases you want, and know that that is going to give you a certain level of functionality kind of out of the box. Great. Any other questions or comments? Cool. All right. Yeah,
I
go
would
ahead,
just say,
Josh.
sorry, Jenna. I would just say that as agencies consider going after these data, I think automation in one form or another is going to be probably the only feasible way to do it. And so staying abreast of some of those efforts and coordinating with folks on the GATIS committee would be really useful, I think, for this to help advance the state of the practice and some of these automation techniques and help drive some of these firms that are developing these automation techniques, whether it's terrestrial LiDAR data or photos at the street level, or if it's aerial imagery is the process that ODOT utilized, and getting those vendors to incorporate the GATIS standard into their workflows would be tremendous for the state of the practice, and making sure that the data is collected in a standardized way, that then when agencies get those data deliverables, they can jump right into using those data and not having to do what we're having to do, which is like a whole other data integration project. So just to point that out, that these companies are promising that their data is going to be amazing, and it's certainly leapfrogging and getting us a lot farther than what we have, but we need to point them towards the final data deliverable standards, in this case GATIS, that we want, so that we can use the data as soon as we get it. It's not a trivial thing for these companies, but at least now we have a standard we can point them to and say, collect it and put it in this format, however that's got to happen.
Right, and it could be GATIS plus, right? It could be GATIS, but then also add a bunch of these things, or use this type of field or this nomenclature because this is going to speak to what we're already having another system or something like that. I think that's important. It's standardization with flexibility built into the tier system and extensibility to accommodate things beyond the scope, and as a sort of ongoing specification. I mean, it'll never be sort of done, right? It'll always be evolving, with input from folks like those of you on the call who are dealing with this and can help shape it, as those who have helped shape its where it is today. It's got to be based on what users actually need. Any other comments or questions? I think I have some slides here at the end that I'm supposed to cover. Okay, so upcoming, we have 2 more quarterly sessions this year, using non-volume data for pedestrians, looking at dwell time, place vibrancy, and activation in September. So how sticky is a place? It's a term I like, urban designer term. Just frankly, economic development term and land use development. And in December, micromobility data and classification, looking at safety, speed, and types. I know this is a hot topic. There are a number of states that have been coming out with legislation, or developing legislation around micromobility to help sort of put some sort of legislative frames around the myriad devices that keep popping up. I assume in 6 months from now, it'll be an entirely different presentation than it would be today. So stay tuned for that. Thank you very much for participating. If you want to see any of the previous sessions, go to this link. And let me see, I can copy and paste this into the chat. Great. Well, thanks for joining us. Hope everybody has a lovely rest of your week. We'll talk soon.
Thanks, everyone.
Thanks to our presenters.
Thanks.
Bye.
Bye.